Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today, it's my pleasure to welcome Himanshu Jain, the T.L. Diamond Distinguished Chair in Engineering and Applied Science at Lehigh University. Himanshu is also Professor of Materials Science and Engineering and the Director of the Institute for Functional Materials. Thank you so much for joining us. To get us started, could you tell us a little bit about yourself and how you first got involved in nanotechnology?
Yeah, it's a pleasure to be on this program, Lisa. Thanks for the opportunity. So, in the time I was growing up, science and then engineering was the solution to every societal problem. And this is the time in 1960s back in India after the independence. So, I think we always looked up to the science and scientists to solve the problems. And so I wanted to become a scientist, but I also wanted to connect with the solutions and with really solving the problems that required putting science into engineering. And so this is how I consider myself getting into engineering, but via science, and which is great for research purposes so that we can look at problems on a fundamental scale.
So I understand that a lot of your research focuses on the use of glass or the properties of glass. Can you talk about how that intersects with nanotechnology?
It is a very special material because glass has been known for thousands of years, going back to Egyptian times. At the same time, it is a very modern material. And so we understand the glass a lot more now, but the glass engineering and glass technology has existed for thousands of years, literally, right? And so the special part of the glass is that it is an amorphous material, as we know, and it is an unstable material. So glass is not the stable material, but it can be stable for a very long time, but ultimately it is going to become a crystal. And so as a result, because it is stable on practical time scale, but at the same time it is unstable, we can play with its structure and properties. So it is, for example, a common glass is, let's say, a window glass, which is a glass based on silica or sand. And so in window glass, sodium, calcium, silicon, oxygen atoms are all randomly distributed as we make the glass from the melt. Typically, that's how the glasses are made. But then we can modify the structure and composition of the glass in a very defined way. And that gives glass an ability to produce properties that may not be easily found in other classes of materials. Putting in perspective, so there was this study many of us know by the National Academy of Engineering, and they tried to compile the list of 20 most important inventions of 20th century. What were the greatest accomplishments? And so half of those accomplishments, those advancements in technology and science and society as such, would not have been possible without glass. So for example, high-rise buildings would not have been possible with large windows if it was not for the glass. So the architecture has literally transformed as a result of the glass technology. And take other example, internet would not have been possible. You and I would not have been talking to each other the way we are doing it now if it was not for the optical fiber. So you can see the glass has impacted the way we live, but that was past. And then the National Academy of Engineering also, at the beginning of the century, tried to establish the grand challenges for this century. They came up with 14 areas, 14 grand challenges for the society. A large majority of them will not be advancing if it was not for the glass. So glass is a fundamentally very important material. Now, coming to the connection with nanotechnology, I think it's interesting to recognize that the oldest nanotechnology that I can think of really was established in glass 4th century. So it has been 1600 years since nanotechnology has been part of glass community, and then the ruby glass that was made years ago. And in fact, one of the best known example of the nanotechnology is Lycurgus Cup. It is a museum piece in London, again going back to Roman times. So they were able to make these gold nanoparticles in a glass that ultimately led to the ruby color, for which the ruby color has been known, was the first example of glass technology put in real life. Now, there, of course, have been many more advancements of the use of control of glass structure on nanoscale, and that has been leading to a slew of new areas. For example, optical memories. The storage of information, the rewritable DVDs, they are based on a glass film. And in that glass film, the structure of the material is modified, producing interesting properties. They carry the information, they store the information. So I think there is continuous use of glass in nanotechnology, and certainly many more exciting things are happening at the current time.
Can you talk a little bit about the instrumentation that you use to do your research?
Yes, so the science has been building up for now hundreds of years on the atomic scale. So what has changed over the years is the instrumentation, our ability to observe and to modify materials on the nanoscale. And so nanoscience, I would argue, has been there for a long, long time from the beginning of science, but nanotechnology has not been. And so our ability to change the structure, and there are conventional ways, let's say, take a piece of glass and put it in a furnace and let the glass crystallize, and you can stop the crystallization when the crystals that are forming are of the right size. And so this is how the Romans made this Lycurgus cup. But now we can do that with electron beam. We can do that with lasers. And we can do much more precisely than, of course, was possible in the old days. And so coming to the observation of the nano structures, we use high-resolution electron microscope, where we can look at the nanoparticles or the structure created on nanoscale directly. But often it is not necessary to look at individual nanoparticle. We just want to look at the effect of collection of nanoparticles or nanorods and nanostructures as an assembly. And then one would look at the physical properties, then connect the properties to the nanoscale understanding of the material.
So I want to switch gears a little bit and talk about your institute in the concept of interdisciplinarity. We often hear that in nanotechnology, it's important to bring together people from different disciplines. Can you share some thoughts regarding your experience working across disciplines?
Yeah, I would even say it more generally. Anytime there are unexpected advancements happening, to make use of those advancements, it is extremely important that people from different perspectives come together. So the discovery alone does not create an impact. It is just the beginning of creation of the impact. And so nanotechnology, because we are able to observe materials and their characteristics at the nanoscale better than before, we are learning so much more about them. But that's one thing. But if we want to convert that into nanotechnology, it is extremely important that people from different backgrounds come together and then make use of what is being observed on the nanoscale. And I think because there are so many new observations happening on nanoscale, because of our ability to make the materials, control the materials, observe the materials on nanoscale, I think it is especially important for nanotechnology to be interdisciplinary.
So you work with students who are interested in pursuing a field of engineering or science that involves the study at the nanoscale. Do you have any particular advice that you share with them?
My advice will depend on what career these students are seeking. And so the students who are looking to get in the workforce after graduation with a BS in some science or engineering discipline, the advice will be that nanotechnology is still at the infant stage. Nanotechnology is a great minor, but you need to have a basic strength in one of the traditional fields. And then if you know about nanotechnology, I think you'll be very useful and will be marketable. On the other hand, I think the options for research are many more. So if someone wants to have research career, because the advancements in tools and the materials and our ability to study materials and devices on nanoscale has been expanding. So there's a lot more growth area. So it depends on what the career choice the student wants to take.
Well, I think that that's certainly good advice depending on what path they plan to take. And I want to thank you for taking the time to talk with us today. Do you have any closing thoughts that you'd like to share with our listeners?
My experience has been largely working with glass. Coming from that background, I would say the glass is a traditional material. It is sometimes does not strike as a very fashionable material because it is so well known. But I would say don't worry about these fads. Be an expert in an area, especially for the students I'm speaking. Be good in one thing and keep eyes open for what else is happening around you. And you'll be surprised at how much people want to know from you because you are expert in your subject area.